السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. Dear students, today we're going to talk about the practical for the bone tissue. The bone is a type of a connective tissue in which the matrix is solid due to the position of calcium. From the anatomical point of view, the bone either short, long, irregular, flat bone. Histologically, the bone classified into compact and spongy bone. First, we're going to talk about the compact bone. Here is, look at the title, dear students. This is decalcified compact bone. The word decalcified means we remove calcium from the bone section. Why? In order to be easily cut and stained. Okay. We're going to take the bone from a shaft of a long bone. We're going to take the decalcified compact from a shaft of a long bone. Here is a long bone. Okay, I'm going to have a TS section like this. Okay, so it will appear as rounded structure with lumen. It will appear as round structure with lumen. Here is the bone marrow, and here is the muscle, and this is the bone. Compact bone. Okay, so it is a decalcified compact. How I do the decalcification, as you know, in order to precipitate calcium, we put an alkaline phosphatase. In order to remove the calcium, we'll put it in acid media, nitric acid, for about 1.5 months. And I'm going to remove the calcium from the bone to be easily cut and stained. A higher magnification, I can see here the bone. This is the bone marrow cavity. I can see many fat cells, so it is yellow or inactive bone marrow. And here is the skeletal muscle. Here is the compact bone. The structural units of the compact bone, something called Haversian system, which is formed of Haversian canal, concentric bone lamellae, and osteocyte inside lacuna. Dear students, this Haversian system is cylindrical. If I draw another Haversian system like this and one like that, cavities will appear here between the Haversian system, between the Haversian and the periosteum, between Haversian and endosteum. This is not accepted. Why? Because it's compact. So what will happen? Here is the endosteum formed by is formed of osteogenic cells. The osteogenic will give osteoblast, and the osteoblast will form the organic and inorganic component. It will appear parallel to the endosteum, so it's called inner circumferential lamellae layer. Between the Haversian and the periosteum, the inner osteogenic of the periosteum will give osteoblast, and the osteoblast will precipitate the bone. We're going to form the organic component and calcified matrix, forming the external circumferential lamellae. Between the Haversian system, interstitial bone lamellae will be present, will be formed. A higher magnification, this is the Haversian system. Haversian system, in between there is the interstitial bone lamellae. The Haversian system is formed of Haversian canal, concentric bone lamellae, osteocyte inside lacuna. This is a diagram. Here is the Haversian system, a Haversian canal, concentric bone lamellae, one inside other inside other. In between them, the osteocyte inside lacuna. Okay, this is also diagram showing the how the organization of the spongy bone. This is the periosteum, and this is endosteum. Here is the Haversian system, which are cylindrical in shape. Okay, formed of Haversian canal, concentric bone lamellae, osteocyte in between. These are the Haversian canal. This is what's so-called the Volkmann canal that connect Haversian with Haversian, Haversian with periosteum, and Haversian with endosteum. Another way to see the slide of a compact bone, something called ground compact bone. What's the meaning of ground? It is the past tense of grunt. Okay, I'm going to have a saw and I'm going to cut the bone into very transparent sections, and I'm going to put it on a slide. I will not stain it. Okay, so the cells here is not conserved. All the living cells will die. As you know, while fixing a section in a formalin, I'm going to fix it in a stage like as if it's alive. But here I don't have any living tissue. Here is the cavity of, here is the air inside the Haversian canal, lacuna, canaliculi. Okay, here the matrix. Okay. Again, here is a ground compact bone. Here are the Haversian system, Haversian canal, concentric bone lamellae. Here are the lacuna and canaliculi. In between the Haversian, there is interstitial bone lamellae. Here is Haversian canal. I'm still, it's just in an immature Haversian system. Again, this is ground compact bone. This is the Haversian canal. Here is the lacuna, canaliculi. Okay, here is the Volkmann canal. The second type of bone is the spongy bone. Here is a diagram showing that the bone branch in anastomose. When it branches in anastomose, cavities will appear. These cavities are the bone marrow cavities. Where could I find the spongy bone in my body? In the center of epiphysis, short, irregular, and flat bone. Why I'm saying in the center of? Because the periphery of the spongy bone is compact in order to not be easily broken. Here is bone trabeculae, irregular bone trabeculae, and here is bone marrow cavity, and here is bone marrow cavity. Okay. Here the meaning of a bone lamellae. The osteoclast arranged in the surface of the bone, they will produce the organic component in front of the cells and at the back of the cells, and then it will be calcified. So the osteoclast will be imprisoned in a calcified matrix, changed into osteocyte, and producing the bone in the form of layers or lamellae. This is a diagram showing different bone cells. The osteogenic cell or the progenitor present at the inner layer of the periosteum and in the endosteum. It will change into osteoclast, which is the bone forming cell. When it is surrounded with calcified matrix, it changes into osteocyte. Here is a diagram for different cells, the osteogenic or the osteoprogenitor, the osteoblast. Osteo means bone, blast, I am a very active, mature protein producing cell. I'm going to form the collagen type 1, the organic component. I'm going to calcify the matrix. When I'm imprisoned inside a calcified matrix, I'm going to change my name into osteocyte. I am mature. I'm going to just maintain the bone. While osteoclast, I'm going to eat the bone or resorb. This occurs in two situations only: during growing of the bone and during healing of fracture. Again, this is a diagram showing the osteoclast and the osteoclast present at the surface. I can easily differentiate between them as the osteoclast is large, multinucleated, while the osteoblast is smaller and have one nuclei. Any cell present inside the bone, it is called osteocyte. As you can see here, it has a processes, and these processes connected together by gap junction, as the nutrition for the bone is very good and it is highly vascular structure. With the meaning of ossification, I'm going to form bone. Ossification, two types. Intramembranous ossification occurs in undifferentiated mesenchymal tissue. It starts in flat bone and ends by spongy. It starts in the site for intramembranous ossification is the flat bone and ends with the spongy bone. While the intracartilaginous, the model is hyaline cartilage. It can occur in short, irregular flat bone and in the shaft of a long bone. It either ends with spongy or compact bone. Here, the intramembranous, this is the membranous tissue. The key for ossification is, or the beginning of the ossification occurs by increased blood supply. I'm having many centers of ossification, a very good blood supply. The UMC will change into osteogenic. The osteogenic form osteoblast, and the osteoblast will form bone trabecle. This occurs in an irregular manner, so I'm going to have bone trabeculae surrounded with multiple bone marrow cavities, from where I'm going to form the bone marrow cells from the UMC. Then the UMC at the periphery of the spongy will form the compact bone, and the UMC again will form the periosteum, which is formed of outer fibrous layer and inner osteogenic layer. So I'm forming spongy bone. Look, dear students, to this photo. This is the bone matrix, which is called the trabeculae. Any cell inside the bone matrix is called the osteocyte. At the surface, I'm having either flat cell. If it's flat, it is osteogenic. If it is oval, it is osteoblast. If it is large and multinucleated, it is osteoclast, as you can see here. This is the osteoclast, and this is another osteoclast. These are osteoclasts, okay? And these are the osteocytes. This is a very nice photo for the osteocyte. It's present inside a lacuna, and this is the processes, okay, connected together. This is the bone. Another type of ossification is the intracartilaginous ossification. Dear students, you know that the model for the intracartilaginous ossification is the hyaline cartilage. At the center of the cartilage, the hyaline cartilage, primary center of ossification will invade here. The primary center of ossification. At the center of this model. This primary center of ossification, okay, increase blood supply. You know that the cartilage is avascular, surrounded with perichondrium. This blood supply will change the inner chondrogenic of the perichondrium into inner osteogenic. So I'm going to change the periosteum, the perichondrium to periosteum. And then the inner osteogenic will form bone. This bone will form under the periosteum. I'm going to form a bone collar and the middle of the shaft. Okay, so the chondrocyte here will die. The chondrocyte here will die. Why? Because I close the diffusion. It needs the cartilage is a vascular taking nutrition by diffusion. Before it will die, it will precipitate calcium around itself, so the chondrocyte becomes surrounded with the calcified matrix and the cell will die. Here, the UMC present at the increased blood supply or the vascular bud here, containing a mononuclear progenitor cell that fuse together forming osteoclast. This osteoclast will decalcify the matrix around the calcified matrix of the cartilage, and osteogenic cells will start to form bone in an irregular manner, and bone marrow cavity will be present in between them. So I'm doing the spongy bone. I want to end with the compact bone, so a stage of remodeling will occur. The osteoclast will open the multiple bone marrow cavity and changing them into one cavity, and the osteoclast will start to form the Haversian system. So I'm changing it into compact bone. Okay. Secondary center of ossification will occur at the here at the epiphysis, but the spongy bone will not change it into compact, just a compact at the periphery, And here is a hyaline cartilage at the articular surface, and at the epiphyseal plate, or what's called the metaphysis, which is the part of a hyaline cartilage present between the primary center of ossification and the secondary center from which the bone grows. Here is the intracartilaginous ossification or growing end of a long bone or epiphyseal plate, or the metaphysis. Here I am hyaline cartilage in the reserve stage or the resting stage. Then they are divided and present in rows, then become mature. Then after becoming mature, calcified the matrix and the chondrocyte will die. Then invasion occur, then spongy bone formation will start. Again, here is the proliferative, maturation or hypertrophy, calcification, invasion, and spongy bone formation. Okay, now we are going to examine our cells. We have two types of bone, spongy and compact. And the compact, we have two types of preparation. So you should say what a type of a bone and what a type of a preparation. This is a decalcified compact bone. Why it is compact? Because here is the Haversian system. Why it is decalcified? Because I can see its stained section. The yellow arrow is the Haversian canal. The blue arrow is the osteocyte inside lacuna, and this is the concentric bone lamellae, and this is interstitial bone lamellae. Here it is spongy bone. Why? It is irregular bone trabeculae between the bone marrow cavity. Any cell inside the bone, it is osteocyte. Here the blue star is the is the bone marrow cavity. Okay, is the bone marrow cavity. Any cell at the surface, if it is oval like this, it is osteoblast. Osteoblast. Here is ground compact bone. Why it is compact? Haversian system. Why it is ground? It is unstained, and I can see the black or the air present inside. Haversian canal, Volkmann canal. Again, Haversian canal, Volkmann canal, Haversian canal. Okay. The lacuna, the canaliculi. This is decalcified compact bone, Haversian system, Haversian canal, osteocyte inside lacuna. Okay, this is spongy bone from where I know, irregular bone trabeculae, and this is the bone marrow cavity. This is the bone trabeculae. Here, the cell present at lining the bone marrow cavity, if it is large, oval, it is blast. If it is flat, osteogenic. If it is large and multinucleated, it is osteoclast. This is a ground compact bone, but the section here longitudinal section. So this is the Haversian canal, and this is the Volkmann canal, and these are lacuna. Please, dear students, this is lacuna, not osteocyte. The osteocyte died. And here the canaliculi. There is the ground compact, again, Haversian system. This is the Haversian canal, the Volkmann canal, the yellow arrow, the red circle Haversian system, and the blue arrows is the lacuna. What this section? It is decalcified compact. What is the visual feature of identification? Never say Haversian system. I cannot see Haversian system. Here is the periosteum, outer fibrous, inner osteogenic. This is the bone matrix, and this is the osteocyte inside lacuna. Okay. Why this section is not white fibrocartilage? Because it is surrounded with the periosteum, and I cannot see the matrix. the scanty matrix, the basophilic scanty matrix of the white fibrocartilage. Why it's not white fibrous connective tissue? The same, because I'm having periosteum and the lacuna surrounding the cell. The fibroblast or the fibrocyte that present in the white fibrous connective tissue, not surrounded with a lacuna. Again, this is a decalcified compact from where I know the Haversian system. Haversian canal, concentric bone lamellae, interstitial bone lamellae, the yellow star, and this is the osteocyte, the red arrow. Again, decalcified compact, Haversian system, the red circle, Haversian canal, the blue circle, concentric bone lamellae, green arrow, osteocyte inside lacuna, red arrow, and the yellow star is the interstitial bone lamellae. This is spongy bone. This is bone trabeculae, and this is the bone marrow cavity. Here the osteogenic cell, the bone marrow, the green arrow, osteocyte, the red arrow, yellow arrow, the bone trabeculae. Here are the osteoblast. Here is growing ends of a long bone, the red arrow proliferation, the yellow maturation. Here is calcification, the green is invasion, and here is spongy bone formation. The label diagram, we have two label diagrams, the decalcified compact and the sponge. Decalcified, surrounded with periosteum, outer fibrous, inner osteogenic. This is the outer circumferential lamellae. Here are the Haversian systems. Between them, interstitial bone lamellae. The Haversian system is formed of Haversian canal, concentric bone lamellae, osteocyte inside lacuna. Between Haversian system and endosteum, there is the inner circumferential lamellae. Lastly, the spongy bone. Here is the periosteum. Here is irregular bone trabeculae, and this is the bone marrow cavity. This cell here is the osteocyte inside lacuna. Here osteoblast, and here is the osteogenic or endosteum. Okay, thank you, dear students. Assalamu alaikum wa rahmatullahi wa barakatuh.